think you're muted, Isa. Or no, actually. Oh, no, I just have headphones that are plugged in that I'm not wearing.
Okay.
There we go.
Okay.
Just me being an idiot. That's all.
It's all good, man.
Well, let's see here. I'll give it another few minutes and hopefully some more people join. Otherwise, I guess we'll just have a nice little one-on-one.
Yeah. No, this is good. I've come across. Well, I'm job searching right now and testing and stuff comes up. So it'll be good. What's up, Danny?
What's up?
Hey, Danny.
What's happening?
Oh, nothing. Apologize for last week, by the way, guys. I had to cancel at the last minute, and I didn't get a chance to actually announce it on Slack. I was dealing with an apartment move. And
are you at the new spot now? Are you going to give us a tour?
It is a very long story, but I'm in the same apartment. I was helping my now ex-girlfriend move into her apartment.
Oh.
Hence the complications.
Yeah. That'll happen.
Sounds like a good time.
Yeah, that was fun. Not.
Yeah, moving is no fun. Moving
already isn't
even
fun.
Worse.
Yeah.
Cool. I'm looking forward to the old testing one. This is pretty exciting stuff.
Yeah, I hope this is helpful. I guess let's just do it. And if people, here's Govani. He's coming in. What's up, Govani?
Hi, man.
All right. So I spun up a little example today to kind of do a little demo. But I kind of wanted to get some feedback from you guys as to what you're hoping to get out of this today.
I was hoping just to get some a nice place to start. I think we're all working in React, and so just getting a sense of how do you build your first test would be really cool to kind of think about. And then are there more complex situations you should be?
Okay.
Yeah. How do you approach those?
Yeah. So I think what I'm going to do is I'm going to do a follow-up to this that deals more specifically with the React testing library. Because today I don't have a project set up to really do a React demo. I want to do a separate one where I prepare something more specific to that.
Cool.
But I still want to make sure that what I'm hoping is I can at least answer some questions, even though we're not going to be using React specifically. Hopefully I can the idea here is to give you some just general guidelines when you're testing, regardless of what framework you're using. And so hopefully you can then take those principles or concepts and tie them in. Because every testing library has its own specific configurations and stuff. And I don't want to get lost in the details of a particular configuration for a particular testing library. But I do want to do a follow-up on that specific topic, which is using the React testing library, because it is pretty cool. But this will be more geared towards Jest, which I believe React testing library does actually use.
Sounds about right.
Yeah. So yeah, hopefully we'll kind of touch on stuff that will benefit you in that way, I hope.
Good. So you can just test like a basically vanilla JavaScript stuff.
Yes. So that's what I'm gonna. My goal is today is to show you how you can just do some basic stuff in Node, and then you can take those concepts and see how it would apply in like a more complicated situation.
Cool.
Node is like really straightforward. Hey, what's up, Steve?
Hey Ben, how are you?
I'm good.
Cool.
Cool. And so, all right. So to start, first of all, when it comes to testing, there's kind of two main types of testing. Today, we're only going to focus on one because I could do an entire Code Talk series on like the different types of testing. And I'm not a tester. I'm not like a test engineer or a QA tester. I just know how to code. Therefore, I know how to write a test for code. So there's kind of two main branches or two main types. You've got well, technically there's three. There's unit testing, which is what we're going to talk about today. A unit test, of course, is just a way of testing a very, very like specific functionality, like at like kind of like a component level, not React component necessarily, but like and at the atomic level, you're testing that like the individual screws work, to use a car analogy or a house or something. You're testing that the screws work. You're testing that the exhaust pipe is the right radius, stuff like that. Whereas a end-to-end test, or it's usually abbreviated as E2E, is when you're testing a process. And those are much more complicated and require usually setting up a whole environment. So when it comes to testing like a web application, for example, what you're doing is you're testing a process. So for example, a login process. You want to test that if I type in my username and a password, I should see XYZ happen, such as and you expect certain things to happen based on certain conditions. So if I put in the correct username and password, I therefore should be redirected to a dashboard. Whereas if I put in an incorrect combination, I should be either redirected somewhere else, or I should see an error message on the form. Whatever your requirements are for that particular situation. End-to-end testing is kind of making sure that the various workflows and processes are occurring as expected based on the input to that workflow. There's also regression testing, which I don't really know that much about it, to be honest with you. My understanding of regression testing is when you are essentially making sure that past tests are not failing and that new features and new functionality being added doesn't retroactively break previously working functionality. I could be I think there's some subtleties there that I might be missing, but that's my understanding. I could be wrong. But end-to-end and unit testing are the ones that like most web developers should be expected to have at least some familiarity with. You should be able to write a test for a very simple situation. So that's what I'm going to my goal today is to show you how to do that, but also some strategies on kind of ways to go about it. So any questions before we do the thing?
Yeah, I have a question. So I've heard of integration testing, and I was wondering if that was synonymous with something that I guess, is that synonymous with end-to-end, or is it?
My understanding is yes. We actually use the word integration testing kind of interchangeably at our work. That could be different in various places, but usually when we're talking about integration or E2E tests, we're talking about the same thing.
So unit, or is it like just broadly kind of saying?
So sorry, yeah, they're end-to-end and integration we
End-to-end,
kind of
okay.
use interchangeably.
I got it. Okay.
I don't know if that's the case everywhere, but yeah, it's when you're testing all the units together.
Got
Right.
it.
For example, in unit testing, you're testing individual atomic elements. End to end, you're testing that all those elements are interacting in the correct way.
Got it.
Does that make sense?
Yep.
Cool. I do want to do a code talk on end-to-end testing. There's this really cool framework called Cypress that I have been meaning to do a thing on. I just haven't had a chance to like prepare for that, but it's on my list. It's pretty cool. We use it at work. So, all right. So unit testing, if you understand unit testing, then all the other types of testing are pretty straightforward, at least conceptually. Like I said, there's a lot, you can go through configuration hell when you're trying to set all these things up. But the general idea, most tests are set up in a very similar way. Let me share my screen. Okay. So okay, here we go. Gotta hide these stupid controls. Okay, can everyone see that all right?
Yep.
Okay, so there are a few things to point out. There are what are called test runners, and then there are what are called like test utilities. A test runner is the thing that actually executes the test, hence the name test runner. And then there's test utilities, and sometimes they're called assertion. And an assertion library would be a type of test utility. That's the kind of, those are things that allow you to make your test running lives easier. But they are two distinct things. So have you guys heard of Mocha and Chai?
Yeah.
So Mocha is a test runner, whereas Chai is an assertion library. So an assertion library is just a set of functions that let you ask questions about actual and expected values. So a test, of course, in a colloquial sense, is just a way of saying, does the actual event happen the way I expected it to? And does it happen in the way I expected based on the starting parameters that I gave it? Right, so when you're testing a program, essentially you're running the program with a variety of inputs, and you're just testing that the output is expected or not. And if they match, then cool, your test passes. And if they don't match, then you did something wrong. Your code's doing something unexpected. So a test runner allows you to run the test, whereas an assertion library, and there's various other utility functions, are what allows you to compare values against each other. And there's lots of different ways that you can compare values together. I'm not going to go into the details, but there's things like, I expect a number to equal this. I expect an array to include X, Y, or Z. I expect this object to have such and such property. I expect this function to throw an error. There's various questions you can ask using an assertion library that help you determine whether your test has passed or not. Whereas the test runner, so in this case, I'm using Jest because Jest actually kind of encompasses everything. Like they have their own built-in assertion library inside, which is kind of nice. There's a few main parts of a test, and they're all very similar. I'm using Jest because that's just what I use, but there's different libraries tend to use slightly different function names sometimes, but the first most important part of a test runner, or sorry, the most important features of a test runner is that it has what's called a describe function. So, oh, and actually, before I even get there, let me just point out the fact that I have a file name that has the word test in it. And depending on what test library you're using, there are different conventions for how to name your test files. And there's also different ways you can organize your tests. I'm not going to go into that, but just be aware there's various ways that you can organize your tests. And it's fully configurable. So you can tell Jess whatever the hell you want it to do. So in my case, I'm just throwing them all next to each other. If I have a file that I want to test, I'm going to write a file next to it with a test suffix. Okay, so that's the first thing. A test file is literally just a file. So there's nothing crazy about that. But all test files, if we're going to do an anatomy of a Jess test, there's what's called a describe function. A describe function is an overarching, this is what tells the test runner that, hey, there's some tests in here. And it takes two arguments. The first one is the name of the test, or at least the name of the part of the test, because you can have multiple describes inside of a file. There's no limit. So usually you have several describes that are kind of relevant to maybe a particular set of functions you're testing. So, you give it a name, you give it a title, and that's what you see when the test runs. It's just a nice way to see at a glance, what failed, what passed, stuff like that. The second argument to the describe function is a callback. And the callback, of course, contains the actual like test contents. Okay. So inside of a describe, you will always have, or inside of the callback to the describe, you're always going to have what's called an it, or there's also a keyword test and jest. I believe they're interchangeable. I believe they're the same thing. I like it because it lets you, I don't know, it just reads better to me. But what this is it just says, this is a definite set of specific tests that I am running. Like these are like the checklist that I'm going through. Okay. And the convention is to say in your message here is what you expect the outcome of the test to be. So looking at mine, I'm writing a phone formatter function, obviously. I don't know why that says some. I was testing that earlier.
So it's another kind of function with two parameters, the name, or what it should do, and then another callback.
Yep, message and then a callback, and then it is very similar. It's or they take the same arguments. It's a message and then a callback. But inside of an it is where you execute, or your code is actually executing assertions. And usually you want to organize this in such a way that like each describe is very specific to like maybe like one function, and then you have a set of its or tests inside of there that are doing like specific assertions. Okay, so in this case, I only have one it because this is going to be a pretty simple test. But I'm going to show you how we could add more if we wanted to. So in this case, what I'm doing is I'm saying it should format a phone number. Okay, so based on a raw number that we feed it, a raw number string, it should then output a string that is formatting the number into what looks like a phone number. And these are all categorically all the same. So I put them all under one it. You know, I would maybe want to test my like typical cases here. And then if there were some edge cases, such as what if the list of numbers is longer than the number of digits it expects? What if I put in a letter and not a number? You know, there's various categories that you can like think about what kinds of inputs your test or your function may take. And this is just totally depends on the test, or it depends on the function that you're testing, right? Whatever those edge cases may be, you can categorize them as you feel is needed. And I just think it's important to kind of group them in a sensible way. So that's what it is for. It's just for grouping your specific tests in a sensible way. So that's it. Describe and it are the only, those are the ones that are built into Jest. They're built into the test runner, and all test runners have something similar. There are a few here that I haven't mentioned, but because my test doesn't use them, but there are some good things. There's some things that you should be aware of. There's something called a before. Before. Okay, which is a function that takes a callback that, as you can imagine, this callback will be executed before every single test. So in a describe block, if you run a before, it's going to run this, it's going to execute this callback before every single it statement in that same block. Or sorry, before does it only one time, before each does it each time. Okay, so there's before and there's before each. And as you can imagine, there's also after and there's after each. In some libraries, there's after all and after each, and there's before all and before each. It just depends on the runner, but the concept is the same. Maybe there's some setup thing you need to do before you run each set of its, that instead of rewriting the same code every time, you can just run this guy. So that's a utility that most test runners provide. Okay, cool.
How do you like to use that before part?
Yeah, so for example, if I'm testing like let's see here, like a server, then I'm going to have in my before, I'm going to spin up the server. I'm going to I'm going to populate the fake database. I'm going to get everything set up in a way that all my subsequent tests can then just run with the assumption that everything's set up. It just kind of gets an environment running. And with some components, you can like create the component, and now you have the component, and now in your subsequent tests, you can, ask it questions and things like that. Does that make sense?
Yeah, thank you.
Cool. So those are kind of the fundamental building blocks of Jest, but also most test runners. There's a describe, there's an it, and then there's before and before each, after and after each. I think there's a couple other ones I can't remember off the top of my head. Those are the ones I use like all the time. So now the most important part of all of this, of course, is the actual assertion itself. So in my case, I'm using this function called expect. And you'll notice one thing I want to point out is that describe and it, I'm not importing these anywhere. They just exist. And that's because when you execute a test runner, it basically populates the global scope with these functions. So that's just something to be aware of. Without the Jest library installed, it would be like, what is describe? It's going to be like, there's no variable called describe. Anyway, so same with expect. So expect is a built-in function that Jest provides, and most test runners have something similar. Chai, so Mocha and Chai. Mocha Mocha might have an expect. I don't remember. But Chai definitely does because it's an assertion library. So, and meanwhile, Jest also has one as well. Expect is literally just a function that takes an input value, presumably the value that you want to test against, right? You're saying, I expect something to match or to be or to equal or to not be some other value. There's a comparison happening. That's what the expect function is for. It's to just make a comparison to one or more values. One thing to note is there's a huge variety of methods for comparing. And like I mentioned earlier, sometimes you want to test that two things are not equal, or that two things are not the same, or maybe you just want to say, I expect this to be null, or I expect this to be a number, or I expect this to be defined. All of these methods exist. And use one thing that you always want to be careful of is and you can look at this in the documentation, is just verify what kind of comparison is being made. So with 2b, that is not the same thing as 2 equal. They're both perfectly valid methods in the Jest library. You can find them in the documentation. They are not the same. 2b is useful for testing primitive values. So numbers or strings, if I want to test that 4 is equal to 4 or, something like that, perfect for that. However, it is not good for testing more composite values such as arrays and objects, because as you probably know, objects and arrays have pass by reference. So when you say two arrays are equal to each other, they may look identical, but they probably won't equal each other because they're a different reference. So like this is not a true statement. And if you try to make a comparison this way using to be, you're gonna have a problem. So it's just something to be aware of. If you want to do what's called a deep comparison or a deep equal, in Jest it's called 2 equal. In Chai, I believe it's called deep equal, but they're the same concept. So this would be what you'd want to use if you were comparing the two objects look the same or the two arrays look the same. Otherwise, to be is perfectly fine. Cool. So if we look at this code, I hope it's pretty straightforward. We're just saying, hey, I've defined a set of test cases. This is just I did this. You don't necessarily have to do this, but basically I've just defined a set of cases. Where the first argument is, this is the input that's going to go into the function, and this is what I expect the output to be, right? And so that's what I'm doing. I'm just looping through all the cases, destructuring the inputs, grabbing the expected value. I'm grabbing the actual value by calling the actual function that I want to test, and then I'm just doing my comparison. And in a nutshell, this is every test ever. It doesn't get a lot different than that. If you're testing a server or a database or something, at the end of the day, you're still just doing something like this. There's obviously going to be maybe some extra setup and configuration involved. And once you start dealing with like mock data and stuff, it can get a little more complicated, but you shouldn't be too scared because at the end of the day, this is all that's happening. We're just making comparisons. That's all a test is. So does anybody have any questions so far?
Are you going to show us what the format phone number function looks like after?
Yes.
Okay.
Yes. So what I wanted to point out though first, before we get into that, is I want to show, I want to kind of emphasize how important it is not just to know like how a test like works, like how to write one, but like how to write your code so that it actually is testable as possible. So there's a few, like, I guess, strategies, tactics that I think are important to remember. So when I'm helping some of, like when I was a teacher and I'd help bootcamp students, and I still help students now whenever I get a chance. There's a few habits that I notice that I did the same when I was learning. This stuff's hard, so it's not a surprise that that students do this. But new programmers tend to be very deliberate in their code, which is a good thing at first, because if you're deliberate in your code step by step, it's easier to learn it that way. You can kind of conceive of it in a more straightforward, step-by-step way that doesn't force you to abstract so far that you lose track of what you're doing. So what I mean by that is, let me put this guy up. So it's very common to just put all of your logic out in the open like this. Okay, so what I'm doing here is, if you haven't already figured out what this does, is I want to type, and I didn't mean to type letters, but we're gonna figure out how to, make this work a little better. So anyways, the idea here is, if I'm typing things in, I want my display to show the formatted phone number. Okay, pretty simple. However, what I see a lot of the time with new students and bootcamp graduates even, is that there is rarely a separation of concerns, or it's not as separate as it could be. Okay, so this is an example of integrated code that is, first of all, it's not testable. Well, it's hard to test. Second of all, there's too many, this function has too many responsibilities. It's not really obvious. Like, there's a lot of implicit behavior here. Okay, so when you're writing code, you want to make it testable. And to make it testable, we want to, first of all, isolate and separate the concerns as much as possible. So in this case, let's look at how we might be able to do that. So
why at first glance is this not very testable? How do we kind of
because what I have to do is, I don't really have a way of extracting this logic from this function into a test very well. Like, I can't, there's nowhere where this function is being like exported. So I can't import it into my test.
Because it doesn't really return anything, so you can't.
Right, really, yeah, this is an anonymous function that's just kind of out in the open. The logic is just like exposed. There's not an easy way to isolate this function and port it around. That's the first principle of writing testable code, is that your code is very portable.
Yeah, this is in an event listener. So like,
this is in an event listener. And so let's see here. So that's kind of the first thing. Second of all, it would be better to break this up into a couple of steps. Okay, so for example, instead of having this callback, first of all, let's look at the responsibilities here. This event listener is supposed to say, when you detect an input change, run this code. This code is grabbing the value from the event, and then it's applying some logic and and at the end, it's setting the text to this thing. Okay, that's a lot of responsibilities, because it's not only responsible for doing the formatting, but it's also responsible for doing the rendering. And suppose I told you that I wanted you to create a new input that instead of formatting phone numbers, formats currencies. Well, you wouldn't, it would be, you don't have there's no foundation here that would allow you to easily do that with a new input. You'd literally just, I guess, create a new input, add a new event listener, and then just put in all your logic. Everything is just thrown into the ring. We don't want to do that. We want to separate this out. So the best way to do this is, first of all, let's give this event listener an actual home. That's kind of the first thing I want to do. So let's just do a on input callback. Okay, so we can now take this guy. And just do that. Okay, so first, there's already a dramatic improvement just from doing that. Is that now, just looking at the code, it's very clear what this function's job is. We can still do better though, because this guy is still responsible for too much. It's responsible for formatting and rendering, but it shouldn't have to be. It should only be responsible for rendering. This is a DOM listener, so therefore its only responsibility should be to render things to the DOM. Okay, it shouldn't care about how or why, it should just do it. So what we can do is put this stuff, in fact, let's, what I'm gonna do is I'm gonna comment some of this code out, and because this is the logic, and by commenting this out, we can now see that, okay, the whole purpose of this thing is to just set the inner text to some formatted value. Okay, cool. Well, that's easy. Why don't we then offload the logic from this function and put it into another function? Okay, and this one will just be called format phone number. And yes, I do have this in a separate file, right? But we'll get there in a second. One step at a time. So format phone number, what we can do now is that this function is now specifically, its only job is to take some raw string, some raw value, and apply this logic to it, and then output it. Okay, so then now we can just say return formatted. And then we don't need raw value anymore. I just have to make a couple little edits here. And then formatted. Okay, so all I've done is abstract away the logic from over here and let this function do the work of that. Does that make sense so far? Cool.
Yeah.
So already, this is quite a bit more concise. And hopefully you can already see how this is quite a bit easier to test, because now I've got, things are isolated a lot more. They're more like Lego bricks now, instead of those like knockoffs where like you don't get as many options, you know, like they like come half built practically. So yeah, so there we go, beautiful. And now, finally though, this is still not ideal, because suppose I wanted to use this same function in other places, right? I have another page that needs to use this. I have like tons of forms all over my application that is going to want to use this guy. So it doesn't really do us any good to just write it in like the main file of the application. Let's modularize this more. And I've already done that. It's over here. So what I'm doing is I'm just going to take this guy and I'm going to put it in its own file. I called it lib, short for library. You'll see that a lot. And so now I have this file that contains functions that are very portable. And I can import them into wherever it needs. And what's nice about this is that now your application is using these methods and libraries in the same exact way your tests are, right? When I go to my test, I'm literally just importing it in, because this guy is just a standalone file with some standalone functions that are isolated. There's no context anymore. We've removed any sort of implicit context or environment to them. They're now just a standalone function that you can execute in any given situation simply by importing it to a new file. And this is kind of the core of writing good tests, or writing testable code, I should say. And what's nice about this is that this is pretty much in line with just writing good code generally. So if you, in the back of your head, are thinking, man, how would I test this? Then there's probably something that you could do better. You can be like, oh crap, I don't know how I would actually test this. That's a sign that like you probably need to break it up a little more. So one way that you can know that you're on the right track when you're coding is to be like, this would be really easy to test. So I think this is probably pretty good code. Now, of course, there's things like efficiency and stuff that you need to take into account. But I think writing code to be tested if you can do that, that's a huge step forward from just making something work. So does this make sense so far? Anybody have any questions?
Makes sense.
Yeah, super good.
My quick question is, so say like you have a large application and you have a lot of these like functions kind of put away in their own file. Mm-hmm. Does it get hard to stay organized, know where everything is, and how would you separate things? Like, yeah.
It gets big, but honestly, if you have files that since there could be lots of files that are similar to this, right? You could have lots of so-called library files. Different developers are going to organize the structure differently. But usually if you're like team lead or whatever, is good about enforcing various standards unique to the application, then it's really not bad, because yeah, the file might get really big, but you just know that it's exporting a bunch of files, a bunch of functions. So, that's fine. And if it gets too big or if it gets too disorganized, you just break it up into smaller files. And as long as you just remember that every single file is just a set of exported methods, it's not too bad. And you can always use Command F if you can't find what you're looking for. But it actually does get pretty easy to manage, even as it grows, because if you're naming your folders sensible things and you're naming your files sensible things, then it's usually not too hard as it grows. Yeah, does that answer your question?
Yeah, thank you.
Yeah. Okay, so let's see here. All right. Now, what I want to do here is kind of show how we can improve this a little bit. So, okay, so right now, if we look at our test, I'm testing only the most like basic things. What if I don't type anything? What if I've typed a incomplete phone number? And what if I've typed a complete number? Now, what I haven't done is, there's some other cases, right, that I think would be important here, such as I shouldn't be able to type letters because letters don't belong in a phone number. So let's write a test that does that. So I'm going to just go ahead and copy this and I want to ignore letters or non-numbers, right? So that means that if I put in like a letter A or a number or a pound symbol, I mean, or like, I don't know, something else that's not a space or something, you could come up with all sorts of things. Well, what I expect to happen is, in this case, I would expect it not to show at all. Okay, and then, and let's say that my first numbers are valid, but then the rest aren't, right? So then here I expect this to be like that. It simply just shouldn't let me type there. Okay, and then that pretty much covers all those cases. So I think we just need two. There's a representative. Okay, cool. Let's see if it works. I'm gonna run my test. Gotta collapse this 1 sec. Okay, got my. Bummer. Okay, so let's see what happened. So should format, it looks like, I know what happened. I missed something when I copied it over. Raw value. Wait. Now read property 0, undefined. Let's see here. Oh, I know why. I wrote this wrong. That should be an array. Oops. Because those are my set of inputs. Okay. That again. I do expect the first one to pass. The second one I expect to fail. There we go. Okay. First one passes. Okay, cool. So all of my typical cases are fine. However, we have a problem. Down here, it says, I expect received to be expected. So the red is what the value I actually got, whereas expected is, what I thought I should get. So that means we have a problem. That means that in the case of putting in a letter A, I get that. Okay, well, that is a problem. So what we can do is we have to fix our function to actually handle the situation. But what's nice about this is that I don't have to go into my app and basically keep attempting to write code that fixes it and then wait for my page to refresh and then type in type in things into my browser and like hope that it works, right? That's kind of how you first learn, but eventually, you know, you want to be a little more efficient than that. So that's what's helpful about this test, is that now I don't even have to go into my app or anything. I can just focus only on this function and be like, okay, how do I make this function output what I expect it to under this situation? So the situation is I have something that is not a letter. Okay. Or sorry, I have something that is not a number. So we got to just handle that situation, right? So, okay, if we look at our logic, we're looping through the template, and then anywhere that there's an X, we want to check to see that the corresponding character in our raw value, we got to do an extra check here. Right now it's just saying, hey, do you exist? But it's got to be a little bit more specific than that, right? So the best thing to do is, why don't we just check to make sure that it's a number? Okay, well, how might we do that? We could use the number constructor. We could use is not a number, stuff like that, to figure that out. Why don't we just put in a, let's do a little check. We'll just say const, we'll get the value from the coercion. We'll just say raw value like that. Okay. Okay, so if coerce is not a number, here's that useful is not a number function. So if it's not a number, then I just want to return the formatted value. We could decide that we want to throw an error as well. There's lots of different things that we could decide to do. But in this case, we're just gonna be like, no, just return what you have so far. If it's not good, then just output what you have so far. Okay, let's run the test. Let's see if that works. Oh, duh. So so there you go. We have a problem. It's outputting only what we've created so far, but it's not doing the rest of the template, right? So what we got to do is make sure to output the rest of the template. So where are we now? Actually, why did I do those as X's? Those should just be underscores. I made this more complicated than I needed to. Cool. So if it's an underscore, then we're good. Cool. And then we'll just say, okay, if it's not a number, then we will do the format of what we have so far plus the template from that point onward. So we'll just slice out where we're at currently. To the rest of the way. And then template. There we go. And there you go, it passed. So we can now, we're pretty confident that when we pass in a value, it's only gonna be a valid number up until the first invalid character. Does that make sense?
Yep. Is there a
Cool.
reason that you wrote like a second case or a second it versus just putting the same one into that?
Yeah. That's a good question. So I did this specifically to kind of separate out the type of expectation I have. This is not necessary. I just as easily could put all of those in there. But because I'm just super anal about how I organize things, I think it is useful to group your tests by the category of cases. So like these would be like your typical cases, whereas these would be maybe some edge cases. Does that make sense?
Yeah. Yeah.
Cool. Yeah. So that's why I did that. And now we could write another one that says like, okay, what if I try to put in more characters than are allowed by the template, right? So that would, in that case, we should probably only output, what is valid. And again, this is up to the developer, or at least whoever is responsible for this kind of behavior functionality. They're going to be the ones that's going to determine, what this function should or should not do under certain situations. But we'll just assume for now that should only output first 9 digits. Or actually, let's be a little, should handle cases where input is too long. So suppose I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1. Go ahead.
Yeah, question on like what do you want to try to test versus like what do you sort of assume works, like do you want to like how would you test that an event handler may be fired, or like if we're popping some kind of error message to the user because of what they're entering, do we test that, or do we just test that it validates, it kicks the right thing off that we know will work, kind of thing?
That's a fantastic question. So there's always going to be kind of a combination of the two. So here's a case where right now, we're assuming that this function is going to be used in any imaginable situation, whether it's a browser or on the back end in Node. In this case, it doesn't matter where it's being executed. Whereas, let's say we're testing this form, right? And that's a case where we would want to show an error message, perhaps, or some visual cue to show that it's an invalid input, right? Or maybe we just prevent the person from typing invalid characters, right? So that's a great question. And usually it's a combination of both. So obviously you want to test at the unit level, at like the bottom level. You want to make sure that you're handling all the different categories of inputs that you would expect. In this case, you're testing that the input is not too long, that the inputs contain valid characters, and that your template is outputted correctly in all typical cases. That kind of covers all the bases there. Then what you would do is you would probably use an end-to-end test. You can also use a unit test. I don't have I didn't set up a browser testing environment for this example. But if let's say we're using React or Angular or something, presumably we'd want to unit test this form. We can assume that this would perhaps be its own little component. And what we would do is we would set up a little test bed is what they call them. And we could then use artificial click events to make sure that the behavior is happening the way we expect it to. So we would unit test the component is the short answer to your question, to make sure that, so in that case, we're not really testing the logic of the actual formatting itself, but we would be testing that the rendering is working. Does that make sense?
Yeah. Okay.
And there are absolutely ways to do that. We could, but I don't have. I'd have to set up like a little browser environment here, and I don't remember how to do that off the top of my head.
No, I was just kind of curious. And then who kind of creates the direction for the number of tests and how much testing you should do? I mean, what code coverage or something? I feel like is the term
it's called code
there.
coverage. Yeah, companies are different, but like usually like 90 to 95% test coverage is considered like robust, because you can't possibly test everything. It's just not going to happen. So you kind of just want to test the most important aspects.
Yeah.
But that's always that's the question for the ages, is what to test and what not to. There's a few things that you definitely don't need to test though. For example, there's no reason to test that. You don't need to test the DOM. You don't need to test any code that you didn't write. And what I mean by that is that you don't need to test any non-application code. So there's no reason to test that the React library is working, right?
Right.
You can safely assume that if the newest version of React is in production, that they probably did a pretty solid testing. They probably did a bunch of tests, so you can kind of assume that that's okay. So yeah, don't test the third-party code that you're using. Just test your code,
right?
And only test your implementations of things. And only test the things that are like relevant to solving the problem that your app is solving. That can kind of help narrow down what to test and what not to test.
In this example, it's like we're testing the formatter, but not that output function or whatever that the event handler calls.
Right. And we could, and like I said, if we wanted to, we would do the same thing with this that we did with this, which is go ahead and put that in a separate file, export it, write a test that can mock up a browser environment, and then trigger a mock click event, and then use the test utils that environment gives you to ask questions about the fake DOM, and be like, hey, does the DOM actually show the formatted phone number value? And you can do that. There are tons of ways to do that. And that's what you would want to do, of course. In this very, very simple case, what we could do is let's say that there are ways to get around the problem of setting up a whole fake browser environment, like a test. They call it a test bed. What I could do is I could do what's called a mock. And in Jest and in Jasmine, there's all sorts of cool utilities that let you do stuff like this. But in a very simple case is, if we look at this event, well, there's really only one tiny part of it that we actually care about in regards to this particular function. It's the target.value. So why don't we, just for kicks, let's say that I have my handlers. Okay, and I'm going to write a test for my handlers. Okay, I'm going to put this guy here. And you'll notice that, oh shit, I forgot about this guy. That's when it gets complicated. Forgot about that. What we could do is we could mock up this guy and also mock up this guy. And in our test, we would just define an object that has e.target.value, and we would define an object that has called output that has an inner text value. And then after the fact, we could just test to see that output.innerText is in fact equal to what we expect the formatted value to be given what we provided there.
Cool. Awesome. I thank you, Ben. I have to unfortunately head out here early, but
No
thanks.
worries.
This was a great introduction. I'm looking forward to the follow-up when that happens.
Yeah, this will be good.
All right.
Word.
See
Well,
you guys.
yeah, see you, man. All right. Does anybody else have any questions?
I think I might have like a general question on like a scale, I guess, and as far as, you know, like if you think about testing in terms of like a startup environment versus a large company or a large that has like multiple things going on, like I'm wondering if there's any, I guess, preference or ideal like trying to phrase this the right way, like basically in a startup environment, my impression would be like you wouldn't necessarily want to write tests, but I feel like maybe that would be I don't know what that is.
A mistake.
Is that a bell or something? Oh.
Yeah, I live right by the Cathedral of Madeleine.
Okay.
So the bell goes off like every hour. So
Okay.
sorry about that.
Yeah, so no, I was just saying, like, it still would be a good idea to just implement tests. I'm trying to like get to that point, like where like you're starting up a new project. They got a few people that you're working on with. Like, you definitely. Is there any is that just like a decision to be made within a group, or is it like an ideal thing that you would want to do? Is that like
Yeah, I mean, ideally you would definitely want to have tests, but yeah, it is very much a, it depends on the time crunch. There's a ton of startups that they just need to get the thing out, and they don't have time to write more code. Which in the short term it might work for a bit, but man, dude, as your app gets bigger, if you don't have tests, it becomes a disaster. And I know from firsthand experience the pitfalls of not writing tests, especially in a large application. In my first job after V-School, besides teaching, so my first job after I finished teaching at V-School, this was a classic case of get the code out the door. We basically, they had this application that was based on a platform that was becoming deprecated very soon. So we had about a year to basically rebuild the whole thing from the ground up using React. And there was very little quality control going out the door. There was no time, as far as management was concerned, to write and configure tests and to build out like a proper deployment pipeline.
Gotcha.
And
Okay.
dude, it was a disaster. It was just awful. Because like you would do something and it would work, and then someone in some other team would push up a change
Yeah.
that a month later you would be working on something and you would realize that that thing that you had done a month ago suddenly wasn't working. But you had no idea when it stopped working, why it stopped working, and then how to fix it. It just became monkeys beating on a car. It's just, it was awful.
All right. Well,
So
actually,
tests are a huge.
I have a
benefit.
question to that as well. I mean, like you have this code base that's like ever expanding. Like, do these tests ever get expanded as well? Like, I guess that's another question that you'd have to.
Yeah. So that's a good question. So now, so at Fidelity, what we do is basically anytime you're making a pull request, the expectation is that there's a set of tests that you wrote to go along with that. So whatever feature it is that you were assigned, you're going to have tests for that. Now, the type of test that you write is going to depend, like whether it's an E2E or maybe it's just a unit test. In some cases, maybe it's just not something that needed to be tested. But like, yeah, essentially, if you set up your testing environment effectively, then it's really no problem just scaling up tests. You just write tests as you finish writing your code, and then you run them and hope they pass. And then you have a pipeline that automatically runs all the tests through the whole app anytime you push up changes to like the for a pull request.
Gotcha.
Yeah.
So like my next. So like yeah. So my next question would be like if okay. So you have to write the test when you submit the pull request. So when if there's say hypothetically down the line somebody goes in and like changes the like source or like the core code that you wrote, like, and you have that test still in the background, be able to trigger when that problem goes off. I guess like I don't know what kind of question this would be, but like is the test that you write like kind of like locked up? You know what I'm saying? Like it's like
no, it's not any different than this, right? Like if I were to commit this project right now as it is, there's nothing special about this file. It's just JavaScript. It's just another JavaScript file.
Yeah.
But the benefit though is that I go in, I write my code, I write my test, I push it up, it works, beautiful. Next release cycle, someone comes in, makes a little change, inadvertently realizing that it was that thing that was changed is actually what's being tested for. Now they push it up, and all of a sudden, one of the tests fails. That's what the test is for.
Got it.
Right. So like that's why you write tests, so that you don't have to. So that basically those things just get caught automatically. Where it's like, and I have to do this all the time. Like when our application is huge. And so I'll go make a change and get it working. And then I run the tests. And then that's when I find out that I've got to add a line of code to one of the tests to make it pass. Basically the idea is if you break a test, then you're responsible for making it pass again.
Yeah. Okay.
That's what tests are
for. That
so,
makes sense. Yeah, it's like kind of like a second barrier. It's like a barrier or like another layer of security in a way.
That's absolutely what it is. And when you have a gigantic app, even when it's not gigantic, the benefit is huge. Because then you're not scrambling, running around, trying to figure out what happened. You just know, this is what happened. Yeah. It's easy. Or at least it's easy to isolate at at that moment that there's something that you did that broke the test. So it's already narrowed down for you quite a bit. So it's a lot easier to fix in that sense. You don't have to come back 2 months later and be like, what the fuck just happened?
Do you have things set up like on your, I guess, pipeline to, like anytime like you commit code, like it'll run a certain amount of test files like that you have written or something? I'm not really sure how that
Yep.
goes.
So anytime that I'm not the one that set this up. I honestly don't know how they did that. They're using what's called, the hell is that called?
It's like GitHub Actions or something, or
No, we're using Jenkins. That's what it's called.
Jenkins. Okay,
Yeah. So that's like a DevOps thing.
gotcha.
Basically, but yeah, so basically it's just it's integrated with our Bitbucket. So we don't use GitHub, obviously it's a proprietary, like private repository, but we use Bitbucket, and basically it's integrated with Bitbucket to detect whenever new changes are pushed up to a branch, and it's just programmed to just automatically execute all the tests and run some builds.
Gotcha. So like so when you write a test for a particular like file, I guess,
Yeah.
it's always going to be on this like this that's going to get pushed up, and like I guess it's up to like DevOps or something like that to be able to. I don't know. Maybe it's like
sort of. This is how it works. I write my code, and then I write my tests. I can run the test locally, of course. There's nothing that I can't do locally that is done automatically on the Jenkins server. But I write my tests, and I run only those tests because it takes a while to run 10,000 tests. So I run my test, and it passes, and it's like, cool. I push it up, and Jenkins then goes, oh, time to execute all the tests. And then it takes like 10 or 15 minutes. And then it spits out the results. We have like a little dashboard that shows the results for every single push that goes up. It's all it's pretty amazing how simple it is. And basically, like, we don't really have like a DevOps guy on our team. We have our team lead who like basically is that. But he's like also the lead developer, so like don't really need a DevOps guy. He just knows how to do all that stuff. But that's basically it. It just you push it up, it automates the tests, and then if it fails, then it lets you know on Bitbucket. It goes, there's like a big red exclamation point that says this build failed, and then you go in and it shows this test failed or whatever.
Gotcha. Okay. All right. Cool.
Yeah, and I think a lot of companies have something similar. At least more established companies probably do. Startups, maybe not so much. Gotcha.
No, it makes sense. I mean, like when you have like a huge freaking, that's another question I was going to ask you. Off a little bit on a tangent, but like as far as like with Bitbucket and GitHub goes, I was kind of curious because I'm actually in a situation where I'm using Bitbucket as well, and like I was wondering. I mean, I know that GitHub has private repos now, so I was wondering if it was like, is there a I don't know, is there like a reason other than that like people use Bitbucket or prefer one or the other that you know of?
I don't know, honestly. I'm only familiar with GitHub and Bitbucket. I hear GitLab is really cool too.
Gotcha.
But I don't know. I don't know enough about it. Yeah.
Like I know, like I get the reason for like wanting a private repo that like like you'd want to switch from GitHub to Bitbucket. Like I don't know. I kind of went through the whole thing with GitHub, so like I'm going to another thing, and it's like, okay, why are we doing this?
Right. Yeah. I mean, they just provide different services. Like at the end of the day, it's all Git, luckily. So like that part's easy, but like, they're just companies, they want to make money. And so they're going to provide different services and stuff. They're all competing with each other to get you to run or store your stuff on their servers.
That makes sense.
Yeah.
All right,
But I mean,
cool.
yeah, a private repo is nice when you need to, like, if you don't want your code to just be open source, then,
Oh yeah.
obviously private is the way to go.
Yeah, man, that's it. I think I'm good. Like,
Cool.
I got a clear understanding of what's going on, I think.
Right on.
So
Cool, man. Well, I hope that was helpful.
Quick question from a beginner who hasn't even
Absolutely.
started tests.
Absolutely.
Where should I begin? Because I mean, I'm really wanting to incorporate this as soon as possible because I see the benefit of it, and
Yeah,
it helps you not run into major issues later on.
totally. So, the first thing is what I would do. So, like I said, there's a lot of different testing libraries and environments out there, and it's very overwhelming. And there's going to be some things that just, as far as getting through the boot camp and stuff, there's just not enough time to like learn how to do the thing, but then also learn how to set up a test environment to test that thing.
Okay.
What I would do, do you like coding puzzles? Like, do you go to like Code Wars or whatever and like attempt little JavaScript puzzles?
Every once in a while.
Yeah, so I highly recommend doing those for anyone, and not just for the puzzle solving aspect of it, which obviously is the main point of it. But what you can do is you can write unit tests for those puzzles. So that would be the first thing that I would do if you're really interested in like kind of getting comfortable and familiar with writing tests. Is next time you're on Leak Code or whatever, it doesn't matter how simple your the puzzle is. It can be really, really useful to try to write some unit tests on your own, because when you go to their site, they have tests already written, and you can run them, and it'll tell you whether they passed or not. But there's something really satisfying about writing your own cases and your own tests and having them pass.
Nice.
So that's what I would do, is next time that you are working on a puzzle, is to try to write some unit tests for it. And what's nice is that you don't need anything other than a testing library installed. So I don't know if I'm assuming that you've gotten to the node part.
Yes. Yeah. Got the node
Okay,
part.
cool. So then literally that's all you need.
oh, just
And then you just need to write a test file that does the thing. You basically have your file that you have your code that you want to test, and then you have your test file which imports that code and then executes that code using the various things. So and there's a lot of really good documentation and guides and stuff online. If you get stuck, just hit me up on Slack and I'll walk you through it. How to set it up.
What was that? So is that something that you installed like Node?
Yeah, it's just like you install anything else. It's just npm install.
Okay, and just.
Yeah.
I was just gonna ask you what npm script you ran, but I didn't see it there.
Yep, it's literally that right there. So
Yep.
it's just jest. And just to point this out, notice this is in the dev dependencies. So Xavier, there's two kinds of dependencies. You're probably used to doing something like this, right? npm install and then the name of some package, right?
Yes.
So whenever you're installing something that's not really like going to be it's not part of your application code, right? Like just, you're not going to use your test code in like your application itself.
Right.
Right. That wouldn't make any sense. Jest is just a utility that you can use. It's part of your project, but it's not, the code isn't actually part of your application. Anytime that you have a case like that, you want to install using what's called the save dependencies flag, or the dev dependencies flag. So that just, it's not gonna like break anything if you do a normal npm install jest, but
Yeah, it asked me. I was doing that while you were talking, and it asked me if
Yeah.
I'm test, git, or list.
yeah, and it's generally frowned down upon to put dev dependencies in your normal dependencies. So just fun fact to remember. Yeah.
All right.
Cool. Well, thanks guys. That was fun.
Yep.
Yeah, man. Good stuff.
Yeah, dude.
Right.
Well, we'll see you guys next week.
What do we got next week?
Any
idea?
Don't actually remember. Let me see.
Is it a part 2 to this?
It is not a part 2. I had not intended on doing a part
Oh,
2, but I do want to do more testing stuff for sure. This one is node packages. So I'm gonna show you guys how to write your own npm packages.
Oh, cool.
Oh, this looks like a duplicate. I'll have to talk to Mo. That's not right. This is right. We're doing that next week. This is not right. I'll have to fix that.
All right,
Anyways,
man.
yeah.
Well,
So npm packages.
cool.
Cool. All right, man.
All right. Have a good night, man.
All right. See you.
See you later.